Combustion analysis is a really useful trick where a compound can be burned, and by collecting and weighing the products, one can figure out what the empirical formula of the compound was. This is typically used on organic compounds, so things that contain carbon. If I have something that just has carbon and hydrogen in it, when I burn it, I'm always going to get carbon dioxide and water, if it's a complete combustion. As you know, if it's an incomplete combustion, we may get some carbon monoxide or some ash or something else as well. So if I know how much carbon dioxide I had, I'll know how much carbon was in this compound, because every bit of this carbon ends up there by conservation of mass. Similarly, every bit of this hydrogen ends up there by conservation of mass. Oxygen can go different places. So typically oxygen will be a more difficult thing to work with in this problem. We can't find it directly, we have to find it indirectly. If I have a compound that has carbon, hydrogen, and some amount of oxygen, when it burns, it's still going to give me CO2 and H2O. I will still get the carbon by knowing how much CO2 was produced. I will still get the hydrogen from that. But when I'm going to find the oxygen for a problem like this, I'm not going to figure out how much oxygen was in here, because unless I know what this is, I can't get that. So what we do instead is, here if I'm going to find the mass of oxygen, I must know the total mass of the sample burned. And if I do, I can subtract the grams of hydrogen and the grams of oxygen in order to get it. Now there's a third type where I could have something that has, I don't know, it could have nitrogen, it could have lead, it could have chlorine. If that is burned, I'm going to get CO2 and H2O still, because the carbon will be converted to carbon dioxide, the hydrogen will be converted to water, and the chlorine will be converted to something else. And you won't necessarily need to know what that something else is in order to solve the problem, because if you know the total grams of this and CNH, you can find Cl. We're going to take a look at a practice problem where I'm going to use the mass of carbon dioxide produced and the mass of water produced in order to figure out the empirical formula of the unknown.